Okay, so the video that we're going to be talking about today is Unit 2.7. This is 1B, and we're going to be talking about exponents and logs. Now, specifically, when we're talking about exponents and logs, what we're going to be looking for is we're going to be looking for just the logarithmic form at this point. What we want to make sure that we're doing is that we're looking at our log form and not just our exponent form so that we can make sure that we know how to convert between one and the other. So our objective today is basically to continue using the inverse functions of exponents and logarithms to solve our equations. So before we looked at solving exponential equations, and now we're going to look at solving logarithmic equations. So the first thing that we want to look at is we want to look at what we know already before. So we have our exponential form b to the x equals y. And then we have our log of y in base b is equal to x, where x is kind of that exponent that we've been looking at. And so we kind of looked at this Ben and Benny model, and then we have b to the power of e equals the number, and then the log of the number in base b equals the exponent. So we want to be able to convert from one to the other. Now we already looked at converting between exponential form into our logarithmic form. Now what we're going to be able to do today is we're going to be able to take that logarithmic form and go back into our others, exponential form. So basically when we're looking at this, we're going to be changing to our exponential form. And the only way that we really have to do that is we just have to remember to identify our base, our exponent, and our number, and convert from logarithmic form to exponential form. And so the second thing that we're going to do is we're going to convert. So first of all, we're going to identify b, e, and n. So in this situation, when we're looking at our log form, the base is equal to 2. The exponent is equal to 5. And then our number is equal to, in this case, x. Now the reason that we want to convert to exponential form is because we can't use it in its current form. Without having a number, there's no way that I could plug in my calculator and get a value. So by changing to exponential form, I'll be able to do that. So what this means is that 2 to the power of 5 is equal to x. And then from there, what I can do with that is I can now solve that, because now I have something on this side over here that I actually know how to do, or I can evaluate, which 2 to the 5th is 32. So x in this case equals 32. So if I write this kind of basically as it was written before, the log base 2 of 32 equals 5. And so I can convert from one form to the other. So I'm converting from this form to this form here. And so that's really all that we have to do in order to change to our exponential function, or our exponential form. So here we're looking at the same thing here. The only thing that we have to make sure that we're being cautious of, and one of the things that I kind of explained to you in class, is that whenever you do not have a base, so here we can kind of see that there's no base. This is what we call a common log, where it doesn't have a base, and the base in a common log is always equal to 10. So just make sure that you're identifying those things and you're coming up with your answer as you need to. So when we look at this, when I have log of x equals 4, that means that I have a base of 10, a number of x, and an exponent of 4. And so now I can take those three pieces of information and convert it to my exponential form. So 10 to the power of 4 should equal x, and that's going to give me 10,000 equals x. And so basically that's all I'm doing in order to convert to exponential form and solve for my value of x in my logarithmic form. Now with the last one, it's just kind of a different idea. It's just now we have an exponent that's negative, but it really doesn't make a difference for how we're going to solve this. So when I look at this, my base in this case is 3. My exponent is equal to -2, and my number is equal to x. So now I can convert that to my exponential form. And 3 to the power of -2 is equal to whatever x is. And in this case, we have a negative exponent, so that's 1 over 3 to the 2nd, or 1 over 9 is equal to x. And so I'm just following my rules and my basic exponential rules or my exponent rules in order to convert to this exponential form so that I can solve for my x in my logarithmic form. And then finally, we have one challenge problem where we have kind of just variables with our bases, variables with our values. And so in this case, we have to find a way that we can reorganize this information and kind of figure it out. And so really, all it comes down to, again, is identifying my base, which is 2x, my exponent, which in this case is 1, and then my number, which in this case is 2x. Now this is going to be a little bit more confusing just because of the fact that we have these other values, but we can figure this out pretty quickly. And so if I set this up in my exponential form, I have a base, notice that I'm putting it in parentheses this time, base to the power of 1 equaling 2x. And really that's all it comes down to. Now I just need to simplify this exponential portion of it here. So 2x to the power of 1 is just simply 2x equals 2x. And now we come into a situation here when we're going to try to divide or simplify for x. We can do this in a couple of different ways. But if I end up doing this, what you'll end up seeing is that I can subtract 2x from both sides so that I can get them both to the same side. And I get 0 equals 0. Now, whenever I come into a situation like this, this is what we call a true statement. And whenever I'm given a true statement like this, what that means is that if my variables cancel away and it's true, it's all real numbers. And basically what that means is that it doesn't actually matter. If you look at just this equation right here, 2x equals 2x, what that basically means is that it doesn't matter what value that I plug in for x, it will always be true. So I could plug in basically anything that I wanted to. And this is something that we call infinitely many solutions, or we can just say all real numbers, because there is no technical answer for x. And we'll talk a little bit more about that in class 2 as well. But otherwise, we just went through the same process that we did before. We set up into our exponential form and then just went ahead and solved it basically the same way that we know how to. So just kind of be able to wrap this up, remember your ben and your log of BNE so that we can convert properly between our log form and our exponential form so that we can solve for wherever x is in either one of those equations. And that's going to do it for this video.